we touched upon a lot. Domain, range, evaluating, difference quotient, limits, graphing, and so on and so forth. But from all these, we had two major concepts that we studied. Can anyone tell us which two major concepts we discussed this semester so far? Huge. Two concepts. Did I say?
Limits.
Absolutely. This is huge. Perfect. Well, what is the other one that we started with, other than those three special products? A big one. That we evaluated for different functions, we simplified it, we calculated it, and we had one almost every time on every homework.
The difference quotient.
Thank you very much. We are going to put them together now. If you remember, I said, who cares about a limit? Well, the explanation is, for the limit, let me just go back to one of the graphs because I wanted to give you an extra example. So for example here, let's say this is the salary of a particular position in a company. And when we are told your limit in this position cannot be more than, I don't know, $100,000 a year. That's your target, that's your limit. So there are many applications of limits. But the one that we are going to discuss right now is, if we put these two together, what is the difference quotient? Very simple. F of x plus h minus f of x divided by h. Now, what am I saying? Why would I put these two together? So, I need to, yes. So, when I put the limit in front of it, so the limit of the difference quotient, of course, when h approaches 0, and I'll explain why h approaches 0, we get a new concept. This is a huge concept in calculus. So, the limits by themselves, we determine limits of functions. The difference quotient by themselves is a different thing. But once we put these two together, we're going to create a very important concept. And I want to explain how we get this. Remember when we looked at the difference quotient, we looked at the graph, we had here x, we had here x plus h, we had here p, we had here q, and this was of course f of x, and this was of course f of x plus h, and we determined the slope of this line. That's what this is. The slope of the secant line, PQ. And I said, if you remember, that h is very, very small. In other words, Q is very, very close here. Why? We're not really interested in determining the rate of change of this function between these 2 points. What we really want to determine is the rate of change of this function at this point. So this is the rate of change of the function between these 2 points. The slope of the tangent line gives us the instantaneous rate of change of this function at point P. So what's the difference? Well, if you ask me, I'm driving from Baltimore to New York, so you're asking me what was your average speed. This is it, the slope of this line. But if you say, when you were passing by Wilmington, Delaware, what was your instantaneous speed, then I have to give you the slope of this line. Again, if I want to tell you, and if you ask me, what is your average speed? Then I have to determine the rate of change between such and such point over 5 hours, 6 hours, 7 hours. But if you ask me, tell me what was your instantaneous rate of change. Look at your odometer and tell me the speed at that moment, at that instant. Then I want to determine the slope of the tangent line. And this is it. This is how I determine the slope of the tangent line. And this is what calculus is all about. And this has a name. So one more time. The difference quotient just gives us the rate of change between these 2 points. Baltimore and New York if you want. But of course I said H is very small, so Q is very, very close here. Why we want Q to be very, very close? Because we are not really interested in this. We're interested in this, the tangent line. And if Q is very close here, and then I make H approach 0, this result will be the slope of the tangent line, which is the instantaneous rate of change. That's what calculus is all about. We want to know if a stock is going up or is going down and what the target is. We want to know if our salary is going up or it stagnates. We want to know how fast the change is here, so we know what to expect and how to forecast ahead. So in calculus, we're interested in instantaneous rate of change of a function, which is the slope not of the secant line PQ, the slope of the tangent line at P. So when we bring Q closer to P, in other words, H approaches 0, the 2 points are not one on top of the other. We say H approaches 0, does not equal 0. P and Q will never be the same point. Then what we are determining is, in this particular case, is a function called f prime of x. F prime of x. Either we read f prime of x, or another way of reading this is the first derivative of function f of x. What does the first derivative give? As long as I have x, it will give the instantaneous rate of change of a function. Also, it will give the slope of the tangent line at P. They are all the same. The first derivative is a function. If you give me x and I plug it in, I will calculate the instantaneous rate of change. In other words, my speed at a particular point on my trip, or the slope of the tangent line at P. So let's see how we calculate this. And then there is more discussion on the derivative. So let's see how we calculate 144. Okay. So let's pick a function. Allow me to pick the first one. I'm going to pick 7, a very simple one. So in number 7 on page 144, we have f of x equals negative 2x plus 5. And I'm going to copy what they want. They want us to find f prime of negative 2, f prime of 0, f prime of 1. Okay? And then we're going to look at a quadratic function. Okay. Good. In order to determine f prime of 2, f prime of 2, f prime of 1, f prime of 0, f prime of whatever, I have to calculate the term and determine, if you want, f prime of x. So, here's the definition of f prime of x. F prime of x equals the limit as age approaches 0 from f of x plus age minus f of x divided by age. So we are back to where we were 3 weeks ago, finding the difference quotient, but now I have to put this operator in front of it. Okay, so let's do that. So limit as age approaches 0. So f of x plus age, negative 2 x plus age plus 5. So this is this piece minus f of x, which means plus 2x and minus 5 divided by age. Remember, all terms without age must go away. This has never changed. It's the same difference quotient. So I have to make sure that those terms without age go away. Okay, so this is limit as age approaches 0, negative 2x minus 2h, these two are gone, plus 2x divided by h. And look at this. As expected, all terms without h are gone. Then I rewrite limit as age approaches 0 from negative 2h divided by h, exactly as before. Now the ages must h from the top with h from the bottom. So the limit is, can anyone identify the limit for us? What is the final answer?
Negative 2.
That's it. So for f of x equals negative 2x plus 5, can anyone tell us again how much is f prime? We just determined it. For the function negative 2x plus 5, f prime is? Anyone?
Negative 2.
That's it. Indeed, negative 2. So this is negative 2, this is negative 2, and this is negative 2. I don't have anywhere to plug it in. So f prime of negative 2 is negative 2, because there is nothing else. F prime of 0 is negative 2. And also f prime of 1 is also negative 2. So this is the real function, but this is a function that gives the instantaneous rate of change of this function at any point. Okay, let's look now at a quadratic function. Can anyone choose a quadratic function from here? If not, I will. Any quadratic function that you would like to work with?
We do 14.
14 is perfect. So we have f of x equals 5x squared minus 2x plus 7. Perfect. Good. I'm asked to find f prime of, what was it? F prime of negative 2, f prime of 0, and f prime of 1. I have to find f prime of x. I know it's cumbersome, but that's what I have to do. Limit as age approaches 0 from f of x plus h minus f of x divided by h. Okay. So limit as h approaches 0. I have to plug in x plus h. I have to plug in x plus h. 5x plus h, everything squared, minus 2x plus h plus 7. So this is done, so to speak. Minus in front of the function. Minus 5x squared plus 2x and minus 7. Okay. Can anyone square for us x plus h, please? And of course, 7 with negative 7 will go away. Can anyone square x plus h for us, please?
X squared plus 2xh plus h squared.
Excellent. Thank you so much. X squared plus 2xh plus h squared. Do not distribute before you square, please. Minus 2x minus 2h minus 5x squared and plus 2x. Remember, the target is the numerator. Everything that has no h must go away. So the 2x with a negative 2x. I continue. Limit as h approaches 0. Now I distribute 5x squared, 10xh plus 5h squared minus 2h minus 5x squared over h. Again, negative 5x squared with positive 5x squared. Exactly as we did before. What is the next step? What do I have to do now in order to eliminate the h in the denominator? What do I need to perform? What operation do I have to perform at the top? What did we do last time? We worked on the difference quotient.
Factor out h.
Excellent. It's the only way to simplify the h in the denominator, because that's the problem. It gets 0 in the denominator. I don't want 0 in the denominator. So the numerator has 10x plus 5h and minus 2. Now careful. Let me write it one more time before I ask the question. You understand how important it is for you to redo all these problems that we do in class. It's the only way to cement the understanding and the skill. Please. I don't mind begging my students. I implore you to redo the problems we did in class first, with a video in front of you. Okay. Now, h approaches 0. Can anyone give us the answer? You cannot touch anything else. You cannot change anything else. Just h approaches 0. What is the final answer?
X minus 2.
This is it. Thank you very much, because this approaches 0. H approaches 0. This is the only term that goes away. No one can touch 10x. There is no indication about 10x or x. And no one can touch negative 2. So, remember what we found out, that for f of x, which is 5x squared minus 2x plus 7, can anyone dictate one more time what is the derivative of this function? So I can write it here so that I can put them together.
Would it be 10x minus 2?
Yes, and we are going to learn this. 5 times 2, 10x minus 2. We're going to learn the rules very soon. The differentiation rules. Now, here, I'm asked to find f prime of negative 2, f prime of 0, and f prime of 1. All I have to do is plug in -2 and give me the answer. Please plug in 0 and give me the answer. Please plug in 1 and give me the answer. When you plug in -2, what do you get? -22. When we plug in 0, what do we get?
-2.
Perfect. When we plug in 1, what do we get?
Eight.
Perfect. What does this all mean again? When we graph this function, you will see it will have a minimum. How do I know? The leading coefficient is positive, so it has a minimum. So at -2, let's say this is x equals -2, look at the slope of the line. This function is decreasing fast. Look at the slope. Very steep. -22. So the slope is -22. At 0, let's say 0 is somewhere here, look at the slope. The slope of -2. Yeah, not too bad. The slope, -2. What about at 1? Look at what happens at 1. The function is increasing at a rate of 8. This is the slope of 8. This is the slope of -2. So we learned a lot about the function. It decreases very fast here. It still decreases, but not that fast. And here it's increasing very fast at this point. That's the meaning of these numbers. I think I have 2 minutes maybe? Yes. I just want to share my screen and just look at a graph here. And I'll stop after that. So I'm going to just pick a graph. It doesn't matter which one. So let's say 27. Look what happens here. And we're going to discuss this again on Monday. See, this function has a removable discontinuity here. At that point, you cannot determine the rate of change. It does not have a derivative. If the function is not continuous, like here, it has a removable discontinuity, the function does not have a derivative. If you want to find the rate of change of this function at this point, you cannot. Also, see at this point, it's a corner. At this point, the function is continuous, but you cannot find a derivative. Why? Because it has two tangents, a tangent going this way and a tangent going this way. So if the graph of a continuous function, this is continuous, has a corner, at this point you cannot find the rate of change because the function does not have a derivative at this point. The same thing here. Where it has a corner, the function is not, we say it's not differentiable. You cannot find the rate of change at this point. The same thing at this corner. And the third possibility is where there is a vertical tangent. This is not a vertical asymptote. The function is continuous. The function exists. But the tangent at this point is vertical. So at these three different possibilities, not continuous, corner, or vertical tangent, no one can find the rate of change or the derivative of the function. Same thing here. It's also a type of a corner. it has a tangent this way and a tangent this way. So we're going to talk about graphs a little bit and then move on from there.